Greetings. Let's do some more mapping. Here, let's map a table of data. Now, as you know, GIS, Geographic Information Systems, contains the G part. It's the map. It also contains an I part. It's the table behind the map. And that means if you have a table of data, you can map it. Let's find out how to do that. Let's go to, in a browser, to your existing ArcGIS online map that contains your two hikes, the Chaparral hike and the Piccadilly, Manchester, UK hike. Use the Add button and add a layer from File. Navigate on your computer to a folder where you've stored this Melbourne Pedestrians TXT or CSV file. Select this file and add it to the map. Smart Mapping will attempt to symbolize your data for you by your point number, and your map will look similar to the following. You can go ahead and change the base map to OpenStreetMap if you want, which is what I used, but you can use any base map. Then go ahead and change the number 1, choose an attribute to show from point to PEDS AM, PEDS in the morning. And number 2, change the color to red or something else, or from a circle to some other symbol of your choice using counts and amounts size symbol as shown here. You are now mapping morning pedestrian counts. Go back to your map. What spatial pattern do you notice? Go ahead and set a bookmark here and name it Melbourne City Centre, Australia, or something similar. Click on a few points on your map. Do you see the pedestrian data that you've entered, for each point appearing as pop-ups? Note for your future use of spatial technology that the contents of these pop-ups can be modified. Save your map again. Now you're ready to tap into some of the true power of GIS, spatial technology, mapping two variables and building expressions. You ready? Excellent. First, let's map two variables. Because your students went into the field twice and collected data during the morning commute hour and during the time between lunchtime and the afternoon commute, let's say you wanted to compare the two values. First, use Change Style underneath your Melbourne Pedestrians layer. Second, use Add Attribute. Add the Wednesday PM, Wednesday afternoon value, as an additional attribute to map. Then say Done. Your map changes so that the color of the circle represents the morning pedestrians, with darker indicating more, and the size of the circle indicates the afternoon pedestrians, with larger sizes indicating more afternoon commuters. Knowing this, reflect on what a large dark-colored circle would indicate versus a large light-colored circle. So you're wrapping your mind around two different variables at the same time. Nice. Think outside the box. What if you mapped earthquake depth and magnitude? What if you mapped city size and growth rate, or country population and growth rate, or country access to safe drinking water and life expectancy? Ooh, lots of things here that you can map. Okay, I'll calm down a bit. Now let's use an expression for further analysis. As you've already seen in your use of filtering in this module, remember that where we filtered and we actually wrote an expression in there? Well, here we'll use an expression to analyze the difference in morning versus afternoon pedestrian counts, specifically dividing the morning count by the afternoon count. Do this as follows. Change Style. Under number 1, choose an attribute to show. Select New Expression as follows. In the dialog box for New Expression, click on Feature Pedestrians AM, and then enter the / for the divide arithmetic operator. Then click on Feature PEDS PM, Pedestrians Afternoon, so that your expression looks like this shown here. Your expression will be built as you click on variable names. That is, you should not have to key in anything except for the dividing operator. Okay? You shouldn't have to key in anything. Once the expression is built, select OK in the lower right. Your expression should look like this. Save your map again. Note the new patterns on your map. The point near the river is barely visible. You can adjust the size of the points using Change Style if you wish. because the afternoon count was more than the morning count, and therefore the ratio is less than 1. Conversely, the northeasternmost point is the largest because the morning count there was nearly 2 times higher than the afternoon count. You conclude that the northeastern part of the city center seems to have proportionately higher pedestrian traffic in the morning than the lower commute time of mid-afternoon, but that you need to gather more points. You decide to revisit the existing sites to gather additional data and also to gather data at new sites. Save your map again. Now let's reflect on the skills you have gained. Now you know how easy it is to add your own data from a spreadsheet, map it, and start analyzing it. You've also learned how to map more than one variable at a time, and you learned how to add an expression. These expressions are called arcade expressions, A-R-C-A-D-E, and they can be used on any data, provide connections with mathematics education, and extend to the power of spatial technology. You can use arcade expressions to customize a pop-up and other things. So think about using it again to compare population counts or food cost eaten at home versus away from home, or earthquakes by size and magnitude, as I mentioned earlier. Congratulations, you have dug even deeper into the power of spatial technology. Thanks.